Hello everyone. So this is the course which is BNE22103 Programmable Logic Control. So this is our group project which is summarize the chapters. Okay, next is to introduce my team members. So first is me, Linda Lo Ewan. My matrix number is AN190179. So I will cover the week 1 to week 5 chapters. So next is Coming Ray. The matrix number is CN190189. So he will cover the week 6 until week 9. And third one is No Ain Nafisa binti Abdul Razak. And the matrix number is AN190076. So she will cover the chapter which from week 10 to week 14. Okay, so let's go to our objective. Our first objective is to planning the PLC presentation using the process sequence description method. So next is define the function of OMROM CP1E based on the function and features. Building the ladder diagram by using the PLC program, which is using the CX programmer. Solving the ladder diagram by using the timer, interrelay, and other logic gates. Last is explaining how the ladder diagram works with the end of the work online simulator. So next is the safety and health precaution regulation. So first is the design precautions. To install a safety circuit external to the PLC such as the interlock and emergency stop. To make sure all the external load connected to the output does not exceed the rating of the output modular. To build a circuit that has an extra power supply when the main power supply goes off. So the second is the installation precaution. The wiring and the rating of the devices need to be correct. Every processor has its own power rating and number of pins. Make sure the installation of the devices is right before troubleshooting. And to turn off the power supply connected to the processor completely when loading and unloading the modular. So the third is the wiring precaution to make sure all of the terminals are attached to the processor before the modular is loaded. The last is the maintenance precautions which place the processor in a suitable place far from extreme heat which can break the battery and cause electric shock. So this is for the safety and health precaution regulations. So next we are going through the first week for our PLC class, which is the replacement class with the webinar on industrial talk by Festo Dietetic. Yeah, so this is what I do when during the talk. So this is the mind map activity. Yeah. Okay, so this is the clear explanation through the talk. So this is what I do in my mind map. So first is a system is like a fluid and is obey the Pascal law, ability to take a shape, water transmission heat. And the function of the hydraulic system is for transmission, for the control system, and for generation also. So the major area which will use and apply the hydraulic system is the machine application, mining application, and aerospace applications. So what is the advantage to use and apply the hydraulic system? First is the simple, safe, and easy to maintain. So next is highly responsive. Third is easy to control. Easy to control liquid, does not absorb any energy. Okay, so this is the basic principle about the hydraulic system. Okay, so here we can see the hydraulic pump and the pressure regulator. So this is the flow tank. This is the filter through the fuel tank to the hydraulic pump, and we'll go through the pressure regulator. Yeah, so we'll go through the control valve. Okay, so we'll continue go to the flow tank, and the piston here is the light or the weight will go up, push up will pull down. Okay, so this is a basic principle for the Pascal law. Next is the pneumatic system. So the introduction is the pneumatic system is the gases, example is the nitrogen, and to compress the air. For the advantage for the pneumatic system is low cost, availability of air, easy to transport, low maintenance, simple construction, and compressibility of air. The application about the pneumatic system is open and closed door, packing, filling, drying, punching, assembling, metal forming process, preventing harmless industrial robot. So like example which have air engines, HVAC control, vacuum pump, air compressor and air brakes, pneumatic actuator, air guns and cylinder. So this is the example of the pneumatic system. Yeah, so here is the steam in, which is the gases type. So this is all the process and the procedure, how the steam go in and what procedure will going on. Okay, so last for the week one is the programmable logic control. So to introduce the PLC is to compute with one microprocessor, continuous monitor the state of input device, and to design the design for the PLC is can withstand hard industrial operations. The use for the PLC is usually for the paper industrial, medicines, glass industrial, travel industrial, and the cement manufacturer. Okay, next we are go to our week 2, which is the lesson plan. For the lesson plan, lecturer are sharing the information and the knowledge about PLC because we are on online mode to study, so we can't do the physical lab. So for this week lesson plan, lecturer are sharing and describe some activity we're doing in the physical lab, like the mentor-mentee activity, then how the lab going on, and some picture for our senior. Okay, so next we are go to week 3, which is the self-learning through the YouTube. So what is the PLC? A PLC logic control. PLC is an industrial computer control system that continuously monitors the state of input device and makes decisions based upon a custom program to control the state of output device. Almost any production line, machine functions, or process can be greatly enhanced using this type of control system. So, however, the biggest benefit in using a PLC is the ability to change and replicate the operation or process while collecting and communicating volatile information. Another advantage of a PLC system is that it is modular. That is, we can mix and match the types of input and output device to best suit our applications. Okay, so go through our application of PLC, which is oil and gas pump line transportation, wind turbine operation, cement manufacturing, smart factory. And our advantage of PLC is easier than rewiring the relay system. Electronic components are more reliable than relay system, rugged to withstand with vibrations, temperatures, humidity, and noise. Easily programmable and to troubleshoot. Interfacing, and last is the flexible and the robust control. So how does a PLC operate? So there are four basic steps in the operations of all PLCs: input scan, program scan, output scan, and the housekeeping. This step continually taking place in a repeating loop. So the four steps in the PLC operation, the first is input scan, which is detect the state of all input devices that are connected to the PLC. So next is the program scan that execute the user create program logic. Third is the output scan, which is energize or de-energize all output device that are connected to the PLC. Okay, so next to go through the PLC system. So first is we are go through the power supply. So the power supply will convert the main AC voltage to the low DC voltage for the processor and for the input or output interface modular. So we'll go through the memory unit, the RAM, the program containing the control action to be executed by the microprocessor. So next we'll go through the CPU, the unit containing the microprocessor interpret the input signal and carry out the control action according to the program stored in the memory. So the communicating the decision as the actions signal to the output. So go through the programming device to key in the required program into memory. So the programming device also like programming console, personal computer. So the input device example like push button, switches or the sensor. So for the output device example for the solenoid valve, motor, lamp or the alarm. So how does the PLC work? The PLC will receive the information from connecting sensors or input device, process the data and trigger output based on the pre-programming parameters. Okay, so we are continue to PLC operations, the scan process. So the ladder logic consists of the rungs. Logic reads from the left to the right. So each rung represents a specific action controlled by the PLC, starting with an input or series of inputs that result in an output, which is the coil. So this is the input part and this is the output part. So it's from left to the right. Okay, from here we can see the horizontal scanning order, which is the processor examine input and output instruction from the first command to the left in the program horizontal run by the run. So this is from run 0 to run 0, run 1, run 2. So it's from left to the right, left to the right, left to the right. So for the vertical scanning order, which is from the top to the bottom. Okay, so this is also the input part and this is the output part. So we will read from the top to the bottom for the vertical scanning order. Okay, next is go through the input and output memory reference. Under the help menu, select I/O memory reference and check. So this later I will show in the CS programmer. Okay, so from the week 3 until week 4, we got the self-learning and also some modules and standard operator procedure module also. So for the standard operating procedure consists of the introduction to CS programmer, SOP for creating ladder diagram, SOP transfer to PLC and simulator, and SOP example. So this 1 to 4, this is the part which we doing the self-learning from the week 4. So this is an example how we can read and how we can define the module of the PLC. So example for the CP1E, E20SDRA, so how we can create and how we can define it. So the E is to mention the basic model. Okay, so E is introduced by the basic model. So the 20 is mean the 20 input output points, which is consists of 12 inputs and 8 outputs. So we can see here for the 20 I/O points will consist of 12 inputs and 8 outputs. So S is the renewal. Okay, so S is for renewal and none is for the normal. The DC input will define as D. Okay, so DC input. Relay output. Output, this is the output types. Will have the relay output, transistor output, sinking, transistor output, switching. So this is the type which is the relay output. And last, the A is the power supply, which consists of AC or DC. So this is how we can read by ourselves, go through the module. Okay, so next is by using the CX programmer software, show the step-by-step to check the I/O memory reference of CPU1E CPU unit and to explain the input and output bits for 20 I/O point. So the first step we will go through the CX programmer and we go through the help menu and to select the I/O memory reference and choose the select CPU unit, which is the CPU1E. So for the 20 I/O points, it consists of 12 input bits and 8 output bits. So for input bits, it will use the channel 0 only. Yeah, so which from 0.00 to 0.11. So for the output bits, it will use the channel 100 only, which is consists the 100.00 to 100.07. Okay, so first we go through the CX programmer and we need to create the new page. The new page we need to select the device type, which is the CPU1E, and we will go through the new page. So after that, we can go through the help menu to select the I/O memory reference. So in this part, there are a few of choices about the I/O memory. So we need to choose the correct I/O memory reference, which is about the CPU1E. So previously, we say that about the 20 I/O point. So we can see here the 20 I/O point, which is consists of 0.00 to 0.11, and this is the input bit and only consists of the channel 0. So for the output bit, which consists of we can see here the 20 I/O points consists of 100.00 to 100.07. So how we can understand it about the table through this all the digits. So for the 20 I/O points, 0 start from 0 to 11, which is consists of 12. So this is have the 12 input bit. And for the output, consists of 0 to 7. So this is the 8 output bit. Yeah, so if let's say we go to the 40 I/O points, so it is consists of the channel 0 and channel 1. And so this is total will be the input bits about the 40 I/O points. And also for the output points, the 40 I/O points will consist of the channel of 100 and 101, 101 and also 100. So the total about the input and output bits will be the same as the I/O points. Example for 20 I/O point, which consists of 12 input and 8 output. Yeah. So this is how we can check the I/O memory reference about the CPU1E.
Okay, so now I would like to share how the wiring connection by using the on-ROM CPU1E. So first for the input terminal, it used the channel 0, which is from 0.00 to 0.11. So the L1 connected to the live, L2 is connected to the neutral, earth to ground. So for output terminal, it is used the channel 100, which is from 100.00 to 100.07. So each output bit will split with the difference COM port. So for the 100.00 and 100.01, which will having its own port, on COM port. So for the 100.02 and 100.03, they are sharing one COM port, and for 100.04 until 100.07, they also was sharing the same COM port, which is the one of this COM port. So COM port for the input and output terminal are able to connect either the 24 VDC or 0 VDC. Okay, so next we'll go through the basic ladder logic instruction. Okay, so for the first one is the load. The symbol for the load, and this one is no load. This one is N no load. N is mean by series connection, and N is series connection. So this is one is load and one no load, and this both is load. And all is mean parallel connections, and all node is parallel with the no load connection. So this is the all load parallel block. So this will have one block, two block. So for this is the N load. N load is one series block, which is parallel and will series. So the circle is described by output. Okay, so this is some of the example from the previous part lah. So this can see here we have the two blocks. Yeah, I already mentioned the block here. So we can see here the first one is the LD. LD is mean by load. Load what? The input is 0.00. So we load 0.00 and N to 0.01. So why is N? Because it's series. Series to 0.001 input. So we can write it as N 0.01. So for the block 2, the block 2 also the same method, which is use the load 0.02 because the input is 0.02 and this is not the not load. So this is the load. So we use the load 0.02. And the same method is N series with the 0.03 input. Okay, so this is a very basic method. And this one is another way and another different method to see how we can determine the mnemonic code. So for the block 1, start from the input 0.05, 0.06, 0.07, and 0.08. Okay, so for the block 1 is same load 0.05, and we can't go it straight for go through the 0.07 because we have said that we need to read the ladder diagram from top to bottom and left to right. So we need to settle the top to bottom first, then left to right. So we'll go through the 0.07, which is parallel to the load 0.06. Yeah, 0.06. So this is one part finished, and we will go through another part, which is the block 2, which is the load 0.07 or to 0.08. Yeah, so this is some of the example about the logic instruction. Okay, so this is the table combination summarize about the logic control. So this is the logic gate, and this is the name of the logic gate. This is the sample of ladder diagram, and this is a mnemonic code, and this is the output of the logic gate. So we have the AND gate, OR gate, NOT gate, NAND gate, NOR gate, and XOR gate. So for the different logic gate, they will have the different ladder diagram, different create about the ladder diagram, and also the different mnemonic code. Okay, so let's see, this is the example how to write the mnemonic code. This is a bit complicated compared to the previous two. So this is the combination of the load, no load, series or parallel. So this is the one of the basic ladder diagram lah. So from here we also need start from the step 1. So run is the run 0 and step is how many steps we use. The instruction is what is the condition and what we use in the ladder diagram. And operand is the input or output that we need to write the input or output, and the comment is the label of the each input. So we start from step 0, which is the label F. Okay, so F you can see here is the no load. So we need to write the no load in the instruction part, and we need to also write the input, what is the value of the input about the F command of F. So this is the 0.07. Yeah, we just need to follow them, follow the input, follow the command, and follow the instruction. So next we go through the step 1. Step 1 is 0.1, which is the command I. So this is all to the 0.1 input. So after top to bottom, left to right, so we go through the 0.08. So this is the step 2. Step 2, this is also the not load. Okay, so we next go through the 0.09, which is series with the 0.08. Yeah, so the 0.09 we have the command of hatch. So after we settle the top part, we need to go through the bottom part first before we go through another side, another connection. So from here is the 0.11, which is the load, and with the command of J. After that, that is the series, and means series to the not load with 0.00. Okay, so the step 5 is and not. And is series with the not load, and this is the input 0.00, and the command is K. So after the step 5, we go through the step 6, which is the OR ladder. So this part is the OR ladder. Sorry, OR load. So this part is the OR load. After the OR load, we need to AND load. And this part combine this part. So this the connection is the AND, which is the series. So this is the series connection. So after these two step, we will go through the next step, which is the command out with the input 0.01, and this is the AND series. Yeah, so this is very basic. And after that, we'll go through the output, which is the step 9 with the instruction of out, and the operand is Q 100.01, and the command is L1. So that's all for the how to write the mnemonic code. Okay, so that's all for my part. And next slide will continue present by Ray. So Ray will continue our presentation, and thank you very much.
Hi, I'm Calming Ray, and now I'm responsible for explaining about the lesson that we have learned during our week 6. During week 6 is a case study. There are a total of 5 case studies during this week that has been given us by our lecturer. First is I'm going to explain about the float sensor. The float sensor, every case study is being given has been given by a situation, which will be, there are some of the questions that we are going to solve. First is a flow sensor, and the situation is a flow sensor is connected to an input of I 0.00 and pump is connected to an output of 100.00. When the water level reaches the sensor, the pump will start so that the water will be emptied out of the tank. And A, for the input and output identification, first we'll be having an input of 0.00 and an output of pump. Output pump with 100.00. For the input 0.00 is indicated by the float sensor, and the truth table is as shown as this. Float sensor is 1, pump will become 1, active high, and when float sensor is on active low, pump will go to active low. And the Boolean expression is output is equal to input and pump is equal to the float sensor. And this is the ladder diagram that has been shown to build the system. First, a float sensor as an input and pump as an output. When the float sensor is on, the pump will on, and when the float sensor is not detecting anything, the pump will go off. On the second case study, the second case study will be the latch push button. A latch push button is when the button is pushed for the first time and the button is needed to be pressed once again in order to stop the operation. So for this case, for I/O identification, input will be the push button 0.00 and output will be the fan 100.01. And for the Boolean expression, there is output is equal to input and fan is equal to start-stop button. So this is represents the case study, this ladder diagram. So we have a start-stop button in the front and an output as a fan. So when the start-stop button is on active low, the fan will not be on, and when the stop button is an active high, the fan will on. This is the case of a latch push button. And the third one is traffic light. Traffic light, the situation given by is the control unit for a traffic light is so active, the alarm F is equal to 1 if there is a green light in both directions simultaneously. G1 is equal to G2 is equal to 1, or if there is a red light in both directions simultaneously, R1 is equal to R2 is equal to 1. So the I/O identification, the input will be G1 0.02, G2 0.03, R1 0.04 and R2 0.05. These are input addresses. So the output will be 100.02 as F alarm. So this is represented by the truth table. Yes. This is the Boolean expression of the Boolean expression and the ladder diagram of this traffic light. When both is on, G1 and G2 is on, G1 will be on. And if R1 and R2 will on, this one will also be on, the output. And next will be the car. Car as an example of PLC. The situation is if the ignition is on a warning light. If the ignition is on, the warning light will turn on. If the seatbelt is not fastened, the warning light will only turn off after the seatbelt is fastened by the driver and the passenger. For this, the I/O identification input will be 0.06 push button, D 0.07, and P 0.07 and 0.09. 0.07, this one should be 0.08, and S will be 0.09. Output will be 100.03. This is a Boolean expression. F is equal to I times D bar plus P bar times S. So this is represented by the ladder diagram. When all of this is active, the output will active. When both of this means by the seat belt has been fastened and the ignition is off, so the alarm will not ring. Not alarm, is warning light. And the next one is machine. A machine that contains two switches and can only operate if both the button is pressed simultaneously. For this, the I/O identification will be SW1 switch 1 and SW2 switch 2, 0.00 and 0.01. So the output will be the machine with the address of 100.05. So Boolean expression switch 1 times switch 2. This is represented by the ladder diagram. As you can see, both 0.01 and 0.00 and 0.01 is not active, machine will not be active. And when switch 1, 0.00 and 0.01 both active, the machine will be active. That's it. Okay, now I'm going to explain about what have we learned during the whole semester, specifically week 7. I'm going to explain about week 7. Week 7, our lecturer have given us a video which contains PLC instruction that help us more understand about the PLC and more of its instruction and all its construction. So first one I'm going to explain about is the program development cycle. For program cycle development, there will be writing and editing, and compiling and linking, and uploading and running. For writing and editing, there is means by when the program writer or the programmer construct the program code. In our sense is using the ladder diagram on PLC. So on the second is compiling and linking. Compiling and linking is when a process which the program converts the source code to a machine code. And the third one is uploading and running. After the programmer has confirmed that the code or the ladder diagram is free of syntax error, there is no error after compilation, so the code can now be uploaded into the machine or the PLC for running or testing. Next. During the construction and programming of the PLC, we are bound to always having some problem or syntax error. These are the example of the syntax error that we will bound to face when we try to construct a ladder diagram in CX programmer. So this error is meant by element at rung is not connected, which means by this there is an output that is not connected fully. This is when operand 1 is out of range at rung 0. Is when this activity timer is not connected fully into the output. Next is by overlapping rung. And where? What means by overlapping rung is means by this. There's the second rung, that there is this second line of code that should be should be more below towards the rung 2, and this output is not connected over here to the 0 power supply section. And now is this, when this warning appears, is because there is no ladder diagram at all when you try to compile. And this is the successful simulation of compilation work of an online simulator ladder diagram. If you have successfully compiled and simulate the ladder diagram, there will be a 0 errors and 0 warning character here, as you can see over here. So to simulate the ladder diagram, as this is an example of when 2 switch should be active in order to active the machine. First, double click on this switch 1 and click value 1. By meaning of value 1 means by turning on the load. Means and it can be also be explained by active high. So if 1 is equal to active high, turning on, and 0 is active low, turning off the load. And when both loads are turned on, as you can see, the machine is now activated. And now I'm going to talk about the process of transferring the code to the actual PLC. After constructing the code, there is a wire or a cable that will be connected through USB to the PLC in order to upload the code to the actual PLC. So we can see there is a tab or a button here to compile the program, and then the word online. And there will be a message that appear that let us know that we are about to connect to PLC and ask us do we wish to continue. If you click on yes, then if this the next and this command will appear next after you click on yes. This is the program that ensures you if you want to override your PLC. If you click on yes, then you have to wait for the actual transfer of PLC, transferation of the code to your PLC. Next, I'm going to explain about the ladder diagram structure, the structure of ladder diagram. First, this is represented by the step number, and this one is represented by the rung. As you can see, this is rung 1, rung 2, rung 3. For step number 0 and step number 2, we can see that this is step 1 and this is step 2, and this is step 0. Pardon me. This is step 0, this is step 1, step 2. You can see 2 here, and this one is step 3, step 4. Now here there's a number 4 here, and this one is step 5. There's a total of 5 step number here and 3 rungs. Rung 0, rung 2, and rung 3. This line is represented by the condition, and this one represented by the action. and the, is usually connected with the output. There is a 25-volt bus bar power supply over here, and after it reaches here, it will become 0 volt. A ladder diagram is bound by vertical lines called bus bar power supply. The bus bar power on the left always has the state true connected to the 24-volt bus bar. The bus bar at the right has no defined logical state under the standard. It can therefore be considered as implicit, and not all producers implement a vertical right line in the development tool. So this is the condition, and this one will be action. There will be, in most cases, in every ladder diagram, on the condition there will be there will be the input, and then on the action side there will be output. And for safety reasons, machines are often set up to ensure that a machine can only be operated if the operator pressing two switches simultaneously, one by the right hand and one by the left hand. This is to ensure that both the operator's hand will be on the switches and cannot be in the machine when it's operating. So this is when two switches is needed to be pressed to activate a machine. After building this, compile it, and we can see that there's 0 error, 0 warning, means that it can be simulated. This is an example of wire connection. As you can see, like just now, switch 1 and switch 2, when both are not pressed, the machine will not be activated. And when switch 1 and when the power is low, both are not pressed, the machine will not be activated. When switch 1 is pressed, switch 2 is not pressed, the machine will still not be activated. When switch 2 is pressed, switch 1 is not pressed, no activation on the machine. However, when both switches are pressed, the machine will now be activated. And now it's turn for the week 9 and week 10. There is no week 8 because it is our midterm break. So we'll continue with week 9 and week 10. During week 9 and week 10, it is our group assignment or PLC design project. In our PLC design project, we have chosen the project title of two-way traffic light. This is the input and output of our two-way traffic light. And it is start button 0.01, stop button 0.02, and there will be two traffic light, means by 6 lamps: green 0, yellow 0, red 0, green 1, yellow 1, and red 1. The address will be 100.0, 100.01, 100.00, 100.03, 100.04, and 100.05. For the process sequence description of our traffic light, we have chosen simple narrative, which includes step, number, the input, and the output. And for our simple narrative, for when PB is pressed, green 0 lights up for 5 seconds and red 1 will light up for 10 seconds. And when T000 times up, yellow 0 will light up for 5 seconds, red 1 will remain on for another 5 seconds. When T001 times up, green 1 will light up for 5 seconds, red 1 will remain on for another 5 seconds. And on step 4, T002 times up, yellow 1 will turn on, red 0 will remain on for another 5 seconds. On step 5, T003 times up, process is continuously looping. And step 6, when stop button is pressed, the operation is on halt, means it's stopped. And for the second process sequence description, this is represented by the motion diagram. For motion diagram, there will be a start, then this is our command, green 0, red 1, timer 0, timer 1, timer 2 and timer 3. Timer 0 is on 5 seconds, timer 1 10 seconds, timer 2 15 seconds, and timer 3 20 seconds. And we'll proceed with timer 0, then yellow 0 and red 1, then timer 1, then red 0 and green 1 will light up, then we go to T02, and then red 0 will light up and yellow 1 will light up, and then finally we'll go to T003. After T003, the process will be returning to the same motion, means by is looping. The whole process will continuously looping, means it will repeat itself again and again until a stop button is pressed to stop all the operation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nu'ain Nafisa binti Abdul Razak. Matric number AN190076. I will cover from week 10 until week 14. On week 10 and week 9, we do a group assignment PLC design project. So this is our design of the traffic light model. For the ladder diagram, we have 4 timer, start and stop button, internal relay, green 0, yellow 0, red 0 for lane 1, green 1, yellow 1, red 1 for lane 2. I will show the simulation for our group assignment project. So we compile, and using work on a simulator, there is a 0 error, 0 warning. So when the start button is high, the current will start to flow through the internal relay, and the green 0 will light up for 5 seconds. After 5 seconds, the yellow 0 will light up for 5 seconds, and the red 1 will remain on for another 5 seconds. After that, green 1 will light up for 5 seconds, red 0 will light up 10 seconds. After that, green 1 will turn off, and yellow 1 will turn on. Red 0 will remain on another 5 seconds. This process will continue until we push the stop button. So next, on week 11, we have industrial talk, PLC and SCADA application from industry perspective and experience sharing. We have 2 panels, which is from alumni BND. The first panel is Cik Muhammad Syukur Abdul Rahman, and the second one is Cik Natasha Amira binti Rauf. And we have Kalai Mutan Anak Lelaki Siva Sarmugam as our moderator. He's from year 3 BND. We need to do a report about the talk. So on the talk we learn about SCADA. SCADA is a supervisory control and data acquisition, which is it's giving a supervisor an overview of plan, process and process signal converting from analog to digital. Why we need SCADA? Because SCADA can easily monitor from afar. It also save time, minimize error and high profit. So nowadays factory industry using automation, change to automation. Why? Because it will reduce labor cost, increase output production and improve quality product. Next, on week 12, we learn about application. There is 5 examples. The first one is conveyor motor. The second one is semi-automatic liquid mixing application. Next is sequential motor control, latching circuit, and the last one is interlocking motor control. I will show the conveyor motor, for example. So this is the sequence. When we start when the start button press, this one, the motor will be started and the run green lamp, indication lamp, will be active. So the motor run and the box will start move. Proximity switch will detect the box when it arrives at other end. When the box is arrived and the proximity switch found the object, the motor will stop. So the run green lamp, indication lamp will be active and the stop red lamp, indication lamp will active. When we push the emergency stop button, the motor will stop anytime. So this is the ladder diagram for conveyor motor. I will show the simulation. As usual, using Work Online Simulator, so there is a 0 warning, 0 error. When we set the height value on the start button, the current will flow through the internal relay and it will on the motor and run the indicator. During normal latching, we can set the start button low value because the internal relay will keep the current flow. So when we push the stop button, the system will stop immediately and the lamp for stop indicator will on. For next one is on week 12 also, we learn about PLC connection to hardware. So we have learned about the introduction to PLC CP1E and 20 DRA trainer kit. These are the component. This one is input modules, USB port, RS232C port, 24 volt DC power supply, and these 3 is output modules. We learn 3 examples. The first example is momentary push button, both normally open type using built-in switches in PLC trainer. This is the ladder diagram and this is the connection PLC to hardware diagram. So as we can see, the input and output are connected to the ground, 0 volt, and the common port is connected to 24 volt DC power supply. Next one, we learn about a momentary push button, both normally open type using external switches. This is the connection PLC to hardware diagram. There are two methods. The first method is we connect the input and output to 24 volt DC and the common port at 0 volt ground. For method 2, input output we connect to 0 volt ground and the common port we connect to 24 volt DC. This is the connection. So we connect the wire start button here and another one here, same as stop button wire. For example 3, we learn about momentary push button start normally open type using external switches. This is the ladder diagram, and this is a connection PLC to hardware. So we can see the input output we connect to 0 volt DC, 0 volt ground, and the common port we connect to 24 volt DC. Next, on week 13, we have to do a summary video about the whole topic we learned along this semester. For week 14, we discover about process sequence description, PSD. So there are 4 PSD. The first one is simple narrative. This simple narrative have 3 columns. The first column is for step number. The second one is for input, and the third one is for output. We also learn a motion diagram. For the top, we put the input, and the bottom we put the output, and there is an arrow here. For the third one is flowchart. This one is a flowchart symbol. This oval shape we use for start and stop. The rectangle we use for operation. The diamond we use for decision. This shape we use for input, output. The cylinder we use for disk and storage, and the last one we use for subroutine. So this is the example how to use flowchart as process sequence description. And the last one we learn about graph set. So this is how the graph sets look. We have a start, and this one we put the input, and this rectangle one we put the step, and at the outside we put the output action. This line for a loop. When a system have a loop, we use this line, direct links. We also discover about timer and counter on week 14. So timer is instruction that provide the same function as on delay and off delay mechanical and electronic timing relay. It provide the present delay to the control action. So we learn about timer using internal relay normal latching. So we have a one timer, cylinder and lamp. When the start button push, the current will flow through the internal relay and the timer will active 10 seconds. When after 10 seconds, the cylinder will fully retract and the lamp one will turn on. Next one, same with previous ladder diagram, but we change the internal relay using keep instruction. Next, we learn about counter. So counter is a function that blocks that count up or down until it reach a limit. When the limit is reached, the output is set. So this is the ladder diagram using normal latching, internal relay. There is 2 timer, 1 counter, lamp as output and cylinder. we use skip instruction. We use skip instruction in this ladder diagram. So the most difficult topic we think is a case study and counter and timer. For the suitable teaching and learning technique, we think we have to do many exercise and study from the previous semester test or question to improve our skill. So for the conclusion, we able to build ladder diagram using CX Programmer. Next one is know how the ladder diagram work using work online simulator. Next, we learn how to solve ladder diagram using a timer, internal relay and other logic gates. And the last one, we able to define the function of Omron CP1E function. So that's all from us. Thank you.